Hey everybody, it's Mr. Matthew here for our MCAS review videos. Specifically, we're going to be looking at the From Molecules to Organisms video, looking at structures and processes, and this is video number 6 in that series. In this video, we are going to be looking at the learning objective that asks us to construct an explanation based on evidence that organic molecules are primarily composed of 6 elements which form monomers that can further combine to form large carbon-based macromolecules. So really what we're going to do is we're going to be looking at the 6 most common elements that are found in living things. We're going to then define what a monomer is and talk about the 4 major different types of monomers, or types of building blocks that go into the 4 different types of macromolecules in this video. All right, so here we go. So the 6 elements that compose organic molecules are carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. And so sometimes these are referred to as CHONS plus P or CHONSP. And every once in a while, some people do this backwards and they call them SPONCH. I am always a little bit in favor of the CHONS plus P because carbon, hydrogen, oxygen are found in all of our macromolecules. Nitrogen is found in 2 of the 4 macromolecules, and then phosphorus is found in 1 and sulfur is found in the other. So when we talk about macromolecules, we are going to be talking about our carbohydrates and our lipids. We're also going to be talking about proteins and nucleic acids. And so when we talk about carbohydrates, they have carbon, hydrogen, and oxygen in them. And when we talk about lipids, they have predominantly carbon and hydrogen in them with a little bit of oxygen. And when we look at our proteins, they are composed of carbon, hydrogen, oxygen, nitrogen, and sulfur. And when we look at our nucleic acids, things like DNA and RNA, they are made up of carbon, hydrogen, oxygen, nitrogen, and phosphorus. All right, so now let's talk about monomers and what the monomers are for our 4 major macromolecules. So the monomers include amino acids, and amino acids are the building blocks for proteins. So they are the monomers that build up to make proteins. And then we have things like monosaccharides and disaccharides, and specifically monosaccharides would be the building blocks to make up carbohydrates. And then we have nucleotides, and nucleotides are the building blocks to make up our nucleic acids, specifically like DNA and RNA. And then lastly, we have fatty acids. Fatty acids combine with glycerol to produce our lipids. Now, when I talk about amino acids, monosaccharides, nucleotides, and fatty acids, these are all things that are called monomers. And so monomers would be individual building blocks that could be used to come together. And so if I was to bind these together and I make a covalent bond between the different monomers together, what I could do is I could produce a polysaccharide or a polypeptide or a polynucleotide, which we'd probably just call a nucleic acid. Those would all be types of polymers. The 4th macromolecule in here is a lipid, and lipids technically are not polymers. They do not form these long carbon bonds like this, but because of the fact that lipids by their very nature are hydrophobic, meaning they like to avoid water, they tend to cluster together and form these hydrophobic cores that are separate from other molecules. And so while they don't bond together, they do cluster together. So you can just think about taking a drop of oil and dropping it into water, and that oil is not going to spread out throughout the glass of water. It's going to stay in a little glob of oil, and that's because the chemical nature of the individual monomers like to cluster together, and therefore it is one of our macromolecules. All right, so what we've just done is we've constructed an explanation based off of evidence that organic molecules are primarily composed of 6 elements, and those are carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. And again, carbon, hydrogen, and oxygen, they're going to combine first, form our initial backbones, and then nitrogen, sulfur, and phosphorus are then going to be added on, particularly when we look at our proteins and we look at our nucleic acids. And then when we have those building blocks, they can form large complex carbon-based macromolecules, and those are our polymers. And our clarification statements on this are that monomers include amino acids, mono and disaccharides, nucleotides, and fatty acids. And when we look at organic molecules, when we talk about macromolecules, we're specifically talking about proteins, carbohydrates, which could also be called polysaccharides, nucleic acids, and lipids. Now, you should know that on the state exam, you're not going to be required to to know any specific chemical reactions or identify any specific macromolecule structures. Those aren't going to be expected. So while it might be useful to know things like glucose is a monosaccharide and therefore it is a building block to build something like a starch or a glycogen or even a cellulose, you do not need to know those exact background molecules. Again, useful to know, but not required. You probably will be given that information and then being asked to do something about it. Maybe ask about what kind of elements would be found in these types of molecules. And again, it would come from that basis of the 6 most common elements: carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. And because it's a carbohydrate, it'd be those first 3. All right, well, I hope that was helpful, and I'll talk to everybody soon.